In today's video, I'm going to explain and try to show the process of assembling the first three links of this 7 degrees of freedom robotic arm. But before showing how the assembly came out to be, I want to show shortly the process of wire management. So here we have a slip ring, as we will have at each of the joints, and you can see how each side of the slip ring rotates freely. And so the task here was to label the wires and match the wires from one side of the slip ring with the wires on the other side. Thankfully, the vendor from AliExpress made sure that the wires coloring matches from one side to the other one. So if you get red wire on the left side of the slip ring, you also get red wires on the right side. This made the entire process much easier. Once I get the continuity, I basically just start labeling using this Nimbot label printer. Okay, so I'm now trying to fit all the wirings, because basically the wires are what makes this entire setup very messy. And also to see if these slip rings are working properly. And the main concern I have is the fact that these wires are crazy small, crazy thin. Like on the internet, on their website, I ordered them from AliExpress, and they are rated to 1.5 amps per channel, per one wire. And it's so hard to believe that this can handle 1.5 amps. So for the big motor, the NIMA 23, I put together 3 wires per one of the motor wire. Hopefully this will be enough, and this is mainly what I want to try now. Let's see if this will work, or we'll just destroy the entire slip ring, or maybe hopefully not the entire setup. For powering, I have here 24 volts 10 amps power supply that will be plugged in here like so, and then this button will power the entire thing. So you can see when I press this will go green, and the entire thing will turn on, as you can see. So that was a test for the first motor. Now the test is a simple Arduino script that will run each motor one after the other one. So basically this will not put so much stress on the slip ring for now, because if I'm going to power all of them at once, it could get a bit hot. Of course, as a test, you should test the worst case scenario, but for now I'm just trying to see if the entire wiring is working properly. And from here now it starts the process where I'm going to get the first slip ring wires through the first joint, and I will speed it up because that was a very lengthy process. The problem is, you can see here, the wires are going, this is where the motor will come and will hit the motor. That's not good. That's not good at all. And I cannot place this higher because then the shaft will be on the center. It will not be on the center anymore. The only way I could do this is to put this underneath, but then the slip ring will be connected to the bottom side of the shaft, which is rotating fast. Yeah, that's not so good. That's not so good. You can see how the motor is pressing on the wires. Okay, so the parts that needed to be redesigned were redesigned. For example, here we have the slip ring adapter that is just basically some rings, but for the final version the sun gear will have the proper diameter to fit the slip ring. So this is how it goes. It does move freely. Now what is left to do is to connect the two motors. So that's supposed to be for the base electronics. Now I have to put this in such a way that the wires are not going to touch the bevel gears. It should not, because this is coming all the way down to the platform. So it's supposed to be safe, supposedly. First part done. Let's also add this spacer for the gearbox, because I was worried about the fact that the gear might cut the wires. You can see here the wires need to travel around here to this channel. So if the wires are very close to those gears, the gears might cut some of the wires. So let's see. 3, 2, 1, go. As you can see, the first joint is moving, the base, and then the second joint is moving as well. Yeah, I will stop it because this part is supposed to have a slip ring, and I don't want the wires to be caught in the process. Okay, so now I'm doing something that I was supposed to do from the beginning, which is cable management properly. So to do that, I'm going to use this shrinking tube that will hold all these wires together. So I'll roughly measure the length that we need, something like this. I guess this is the amount. So this will go like this in here. We'll come back and we will connect it to on the walls. Okay, so this is the final assembly at this point in the project. So basically I have the three links connected together, and I had to make some very lengthy troubleshootings, mainly on the wiring management, a thing that I definitely did not expect to be so difficult. In here, I have so little space for any wires, and apparently there are a lot of wires that will go all the way through the robotic arm. And so at the root, there are all the wires there. I had to consider that probably in the future. One thing I could change is the height of this, although I cannot print higher than this. So I'll have to figure out a way to make some more space for wires. So initially I wanted to use some velcros to attach them to the walls of this link, but that didn't help so much because in that case I wanted to use these velcros together with the Dupont connections, and that was a lesson that I learned, that Duponts are definitely not the way to go when you have a final product or some robust system. They're very inefficient in terms of robustness. They keep falling apart. So eventually I end up using these connectors. For that I had to design such a fixture, and this fixture was then glued on the side of this link, and in this way everything stay put in here, and hopefully no wires will be damaged. Another big issue that I encountered, it was the motion distribution from this NEMA 23 to the joint over here through the bevel gears. I did not took into account the fact the bevel gear will jump while moving. So then I had no support over here for the bevel gear to keep it grounded. So the bevel gear keep jumping. I haven't tested the system yet in this format, so it's the first time for this test. and let's hope that all the joints will work properly. So let's see. 3, 2, 1, go. So the first joint is working. Oh no, this joint is not working properly. Okay, so next try, another try. So I tried to fix this joint again by constraining the shaft even more, because before the bevel gears that was attached to the shaft was able to go back and forth on the shaft, and since I didn't screw it to the shaft when the force was applied, the gear was just simply shifted away from the other bevel gears, and the entire power transfer was interrupted. So I will power it again, and hopefully this time will work. This is also again a first time, so let's hope this will work. 3, 2, 1, go. So the first joint is working. Let's see if the next joint is working. It does not. Okay, attempt number, I don't know, 4 or 5. Lost track now at this point. So again, I try to improve this joint, and this time I also add the ball bearings in here, because without the ball bearings, of course, the joint will just come apart, and then the connection from the shaft to the sun gear will be lost. So again, it's a first time. Let's see. 1, 2, 3, go. First joint working as usual, and let's see. Joint number 2. Please say that you work. Come on. Ooh, no! It started working and then it stopped. Why? Why is it doing this? Okay, so attempt number unknown, because there were a countless amount of attempts so far. Apparently the main issue was with the bevel gear attached to the NEMA 23. You can see it has this notch that is also on the shaft, but that was not enough strength to be able to move the entire thing, and the shaft just kept rotating inside the bevel gear. So I had to redesign it, and I made an orifice over here and a housing for a nuts, a very small one, you can see here, and with a screw then I just screwed it in place. So let's see, again, trying to power this thing for the first time live. Let's see how it goes. 3, 2, 1, go. Joint number 1 rotating properly. Joint number 2. Oh, finally. Joint number 2 is moving. And joint number 3. As you can see, they are just slightly moving, just because I don't want to stress it too much. This is just to see if the slip rings can handle this setup. But it's good to know that, to see that it can actually handle the torque that's being applied here. Nice. That's cool. That's the test that I want to see. All right. So it looks like this design it will work. So I guess for the next video I will print the next 3 joints and try to assemble them, and also make the wiring inside much cleaner, because right now it's a bit of a mess over here. So I have to clean it up a bit and make sure that it's finished, ready for the final assembly. And yeah, that's I guess what is going to be in the next video. Hopefully, the entire arm robot being built. Yeah, see you in the next one.